this was tied for the most requested. There weren't that many votes, but that's fine. I called it a Lego thing, but it's really my demonstration of electromagnetic waves. And let's just go ahead and play with it, and then I'll explain it. I need to rebuild it a little bit better. But here I have two wires connected to a piezoelectric lighter, and then I have two more wires connected to a neon bulb. Now I'm going to light it, I'm going to spark it, and you can see let's see if we can see that bulb. Yeah, you can see it. I mean, that's awesome. There's awesome just because it makes a spark, but the bulb turns on and there's no connection. I mean, this is just two wires on each side. And what's happening here is this is a demonstration that electromagnetic waves exist. So when I create the high voltage spark between these wires, that generates a changing current in these wires that make an electromagnetic wave. These back wires then pick up that. They detect that. And they produce a very high voltage and lights up that bulb. So this is a neon bulb. They're very low current, high voltage to turn on. So they're good for things like this. It's just fun. And of course, you know, the classic experiment, the classic answer is that Maxwell's equations predicted there would be electromagnetic waves, that they existed. Hertz had a very similar setup to this. And he showed that producing a spark here generated a spark across the room, therefore electromagnetic waves exist. And he said, okay, well, why? Who cares? What's it good for? He said, nothing. Of course, that's not true. Wi-Fi, radio waves, LTE, all those things use electromagnetic waves. The end. I'll make that other demo later too.